In the first half of this video demonstration, a cordless drill is used to power the vehicle to demonstrate the effectiveness and efficiency of this transmission. In the last half of this video demonstration, a 3.5 horsepower engine is used in place of the cordless drill to provide power for the vehicle. When the cordless drill powered mini tractor backs up, the car drifts backwards because it's on a slight incline. When the mini tractor starts to pull the car, the mini tractor's power is automatically increased to the amount needed to be able to pull the car. And when the mini tractor starts to pull the car in the van, the mini tractor's power is automatically increased to the amount needed to be able to pull the car in the van due to the transmission that is in the mini tractor, which prevents the motor from receiving an adverse strain or load, while providing the needed increasing amount of power. The black and white wheel next to the drill is an indicator that shows how fast the drill is going. The faster the drill goes, the faster this indicator spins. Here's a sweeper belt that's on a pulley that supplies tension to a part of the transmission that controls the changing of the speed and the power and torque of the tractor, the gear ratio change. This is how much pressure that is applied to the belt. A slight tension of 2 rubber bands in this case. The amount of tension that is being applied to the belt determines how much resistance to movement of the tractor is needed before there is an increase in the number of rotations of the drill to the same amount of distance that the tractor travels. Take notice to the black and white wheel above the back wheel. The faster this wheel turns clockwise, the lesser the number of rotations of the cordless drill are needed to move the tractor the same distance, which increases the distance traveled for each rotation of the drill, which increases the tractor's speed. Likewise, the slower this wheel turns clockwise, the greater the number of rotations of the cordless drill are needed to move the tractor the same distance, which decreases the distance the tractor travels for each rotation of the drill, which increases tractor power. The faster this wheel turns counterclockwise, the greater number of rotations of the drill are needed to move the tractor the same distance. As the tractor goes over the hill, there is a decrease in the resistance to movement of the tractor as the tractor begins to move on level ground, which causes the tractor's transmission to increase the distance the tractor travels for each rotation of the cordless drill. Increasing the speed at which the tractor is traveling without increasing the power of the cordless drill lessens the amount of energy required for the distance the tractor travels. Here I am using the full power of the cordless drill. I remove one of the rubber bands, which lessens the amount of resistance of movement of the tractor that is needed before the transmission utilizes a greater number of rotations of the cordless drill motor to move the tractor the same distance, lowering the gear ratio. This lesser amount of rubber band tension is better suited to control the changing of the speed and the power and torque of the transmission when being used in this particular application, best suiting the weight of the tractor that is being moved and the low power of the cordless drill motor that is being used to move it. The lessening of the amount of tension being supplied by the rubber band greatly increased the effectiveness and efficiency and performance of the tractor. This transmission is now providing an almost perfect relationship match between the resistance of movement of the tractor and the motor load, making nearly perfect use of the energy being supplied to power the tractor, dramatically increasing efficiency. Gear can be attached to the transmission and used to turn a small generator in place of using one or more rubber bands. I have connected a rope to the throttle that controls the speed and power of the cordless drill to demonstrate that even though there is a perfect relationship between the resistance of movement of the tractor and the power that is being supplied by the motor, that the tractor does not have to slow down when the power is increased, when it is moving up an increasing incline of a hill. Additional amount of power can be supplied by the cordless drill motor by pulling further on the throttle. Increase the power will increase the tractor's speed. Also take note to the torque. Not bad for a cordless drill motor moving this much weight. I chose to use cordless drills with small motors in my prototypes instead of using higher powered gas-ling engines or higher powered motors because I felt they would best demonstrate the efficiency of the transmission. The cordless drill's full power and speed is applied continuously throughout this slow motion video clip and the following full motion video clip. All the changes in the vehicle's speed and power are entirely due to the transmission. When the power is applied from the cordless drill, the rear wheel starts out moving slowly and gains speed, increasing the distance the vehicle travels without an increase in the amount of power being supplied. When the rear wheel begins to move up into the scale, the rear wheel begins to slow down due to the increasing number of rotations of the cordless drill power source that are being applied to move the vehicle as the amount of power needed to move the vehicle increases. The amount of power needed to move the vehicle decreases as the vehicle's rear wheel moves across the top of the scale, causing the transmission to effectively continuously use a lessening number of rotations of the cordless drill to move the vehicle increasingly greater distances as the vehicle's momentum increases. This continuous variable transmission continuously provides the best suited revolutions per minute of the motor or engine during any amount of acceleration and traveling up or down any degree of hill, which provides for the best possible efficiency, fuel mileage at all times, and the best possible acceleration at all times, using the most efficient means of transferring rotary motion, parallel gears. Continuous optimum distance travel per RPM of the motor or engine results in optimum efficiency, fuel mileage, and optimum acceleration.